waxes now.
Yeah, it is.
So this is our first wax room, and this is the mold, and you'll see the molds in the other half of the tour, but there's an artist original in there. It's like a sitting figure, sitting Indian style, and this rubber gets painted or sprayed on as a liquid, and it dries into this rubber, and then we add a shell to it for stiffness because the rubber's soft and floppy. And then all this junk on the floor is wax. And if you've heard the lost wax method of casting, that's sort of what we do, except we don't lose our wax, we get it back. I guess the ancients would actually bury the wax in a hillside of earth and use the earth. So they carefully bury wax with probably earth that had high clay content and build a bonfire on top to melt the wax out and then carefully replace it with metal. But we do it a little differently now, of course. It sounds like a lot of work. So we have 2 pots of molten wax, and we'll fill up some buckets and pour them in there. That's why the mess we'll be dumping them out, because what we want to do is slush the inside of the mold with a layer of wax, and we'll do that over and over again until we get the wax about 3/16 or 1/4 inch thick. That's going to be how thick the bronze is when we cast it. So we don't want it too thick, we'll be wasting bronze. Or if it's too thin, when you go to pour it, the bronze will freeze before it gets into all the places. So once we get our wax cast, we go into this room here.
Sorry, guys.
Thanks for joining us.
So if you guys remember this one in bronze from out front,
WCBU in
so
Peoria.
this is wax of it.
After a 30-year career as a senior partner with a big law firm.
This just came out of the mold, so it's got the, you can see where the seam is and everything. And he's missing some arms. We need to cast those separately. So in this room, they have different tools and things, and they will chase the seam, so they'll fix all the defects that they possibly can in this room. We will cast them, they're right here. The way we made the mold, they're ready to, we're going to cast them separately too, and they'll be welded on in that.
That's right.
The next stage where we make yet another mold for the bronze, it needs to have space to dry, drain, let air in. So sometimes, even if we can do something in one shape, like on this guy, we'll probably chop the top of his head off and then cast that along with it, because we just need the drainage. Otherwise, you've got basically a vessel. You'll see in the next room that we just need the airflow and a way to drain liquid out.
Are the molds reusable, or do you have to basically make
those molds are? We can make hundreds of, we're just putting wax in, and it's only about 190, 200 degrees, so we can make hundreds and hundreds of waxes. But the next mold that the bronze goes in is a ceramic, and that's one use because you have to shatter it to get the bronze out. And also in this room, if you see hanging over there, is what's called gating or sprues. And so the artwork is attached. The cone shapes are basically the funnel that the metal's going to travel into the piece. And then the rest are conduits for metal, or these higher ones are to let air out at the same time. So when you pour the liquid in, it doesn't gurgle and glug. You want it to go down and smoothly fill up, and these allow the air to vent. Like if you upturn the bottle of 2 liter and snap the hole in the bottom, it would just drain out without This is the investment room where we make the next mold. So these, you can see, haven't gotten started yet. And then these just got started, and then these are further along. But basically, these two tanks you see here are liquid ceramic and glue. I don't know. It's a proprietary formula that we get from the people that make this stuff. But it gets dipped. It's almost all solids in there. That's why they have to turn all the time, or it turns into this concrete stuff. So we'll turn it off, dip it in this ceramic, and since it's a liquid, it goes inside, and so you get a ceramic mold of the inside and the outside. It's called ceramic shell casting. I think it was invented in the 70s, and the whole reason there's art foundries at all is because of this method. It makes it so much easier to cast, because before that, I don't know if you guys know what solid investment is, where you would have a wax and you have to suspend a core in a massive monolithic chunk of plaster. It would take days to heat it up and melt the stuff out. This happens really quickly and easily. So dip it in the goo over there and let it drip dry a little, and then these wooden bins have, starting on the left, a really fine, heavy sand, and then it increases in diameter. And while it's still wet, we'll just toss handfuls of it and it sticks to it like a sugar cookie. Let it dry and then repeat that process. So they get dipped maybe 6, 7 times, maybe 10 times if it's a real big piece, because once you're pouring molten bronze in this, you're dealing with hydraulic pressure. It's just like water, so it's exerting force. So the bigger the piece, the more weight's going in there and the more stress it puts on the shells. And the two tanks are a little bit different formula. The one over here is geared to capture the detail, so it's right up against the wax, and then after a few coats of that, the other stuff is designed to build heavy, strong coats, like a backup coat. Any questions in here? Huh?
Is this thing hot?
It's not hot. No, it's just room temperature. It just has to stay moving because there's very little liquid in there. It's sort of like quicksand. If you actually let it dry, I mean, if it stopped mixing, there'd be about that much liquid on the top and the rest would be, so it's really fine ground up ceramic. So when we go, I'll just talk here since it's sort of quiet. The next thing we do when they're finished, which these are almost finished, maybe one more coat. What we'll do is take a saw and chop the top of this to expose the wax, and then maybe drill a few holes here and there, and then these are going to go into an oven that's 1800 degrees or so, and it's to release the pressure. The wax starts to expand and melt, and if there's nowhere for it to go, it'll crack these shells.
Do you do a sintering process on the shells, or do you just let them air dry and then they're good enough for bronze?
Air dry. Did you say sintering or sintering? Sintering. No, it's just made to air dry. But when they go into the furnace and it burns the wax out, we leave it in the furnace for about 20 more minutes, and it vitrifies the ceramic. It's the wax. There's other foundries that will take these and put them in an autoclave, but then they'll still have to, after they get they do that because it's friendlier to the wax. It doesn't burn it because it's just steam. But you still have to take it after that and fire it. So it's 2 steps, and having an autoclave and steam is expensive and not for us. So we do what's called flash firing, where we do both at once. The wax gets burned up a little bit, we lose some, and it gets brittle over time, but we just replace it. We don't have to fool with autoclave. It looks like there's a bunch of them on the floor out there. Yeah. So he's laying out batches to go in the oven. He'll probably be doing it all day. So you can see here where we've chopped the ceramic off. And then where we drill the holes, we put a little red glaze, ceramic glaze, so it survives the burnout. So when we get them back out, we'll know that there's a hole around that red dot somewhere. Because if you go to pour it, you'll see the bronze. These haven't been done yet. Looks like some of these are, so this one's been burned out, so the wax is gone, and it's fired ceramic now. So who asked the question about sintering? So what's the difference between vitrification and sintering?
I think they're the same thing.
Same thing? Because it must be a molecular thing. Because I know there's a sintered metal, isn't that compressed metal, but not to the melting point of the metal?
Right, and they just let it diffuse. So I think the same thing's happening with ceramic, just diffuses together a little bit like a glaze on a pot.
Okay.
Makes sense because ceramic
Good to know.
melting points are way up.
All I know is sintered metal is junk. Like Matchbox cars, I think, are sintered.
Oh yeah.
This is what our bronze that we did. And we get a metallurgy report with it every time, so it's exactly the same, so it can depend on the colors being the same. And there's a lot of different bronze. This is called Alpha Everdur. It's based on the levels of the ingredients. Everdur is like a trade name, but it's 95% copper. They still make some with different materials in it, but I think that's for different applications. I think probably for saltwater environments or different properties, machining or whatever. The welding rod we use is also exactly the same alloy. That's about a ton right there. A little less than a ton. We use a little.
How many bars of bronze typically go into?
I don't really know. We don't count. The bars vary by size too, because you'll have, like this one's kind of small, and this one's kind of big. So they put bars in here until we get to 2,000 pounds, or right around there, and then sell it to us by the weight. The furnace that we melt the bronze in holds about 275 pounds. But again, when we go to do a pour day, we'll pour all day because we'll heat it all that stuff up. So we do that outside, so we can go around the corner. Patina here in a little while. We're finishing the patina on this thing, but we had to put it. It wouldn't fit in the building anymore, so.
This is bronze.
That's bronze. Some of the colors, like this one, the weird colors, it's actually a pigment suspended and bound to the bronze with a chemical. So we don't do those that much, but it's on there pretty good. But it's not, it's obviously opaque. You can't see the bronze. Here's some of the bottles here. It's got iron oxide black. Looks like iron, so that's iron oxide yellow. Cupric, that doesn't look so authentic. Cupric is like this color. Oh, the cupric was zinc mixture. This, we got a whole, there's unlimited combinations of all these chemicals. This is the burnout oven. So that's where those shells will get loaded into the oven. And it gets, you can see it's got a grate and the wax will fall down. It goes through a pipe in the back and puts out the fire and we get our wax back. So that, and then it oven drops down. And then that's behind you is the metal melting furnace. And this stage actually rolls out of the way, but it's up there for the person to feed ingots in and check the temperature and things like that. And so when it comes time to pour, we fill in the grate with bricks, and then we have to preheat those shells because of the thermal difference. So we have to, after we burn them out, we let them cool off and then check them because we can repair cracks at that point. And then on pour day, we have to preheat them back up to 1,800 degrees or so, and then we pour the bronze at a little over 2,000. We heat up the shells, and then we set them in these bins, which are out here where we have room to move around. And we use a smaller metal transfer crucible. So we fill up about a 100-pound little crucible and pour them by hand until we run out. Any questions about it here? This is probably the most material intensive part of the tour. You can actually start to burn bronze. You could probably run it up to 2,500, 2,700, but that would be a bad mistake.
Celsius?
Fahrenheit.
What's the melting temperature of bronze used?
1850, I believe. There's you probably know the term. There's liquidus, or I think it starts to freeze at around 1850. So, and then if you get above 22, 2300, you start to burn off some of the ingredients in it and change it for the worse. And the shells are the same way. They can go up quite a bit, and they get stronger in plastic, obviously, when they're at their temperature. But if you take them past a certain point, they lose a lot of strength, and you have problems again. You pour them, and then you got to start all over, make another wax. We still have occasionally. Someone will be moving the shell and just clip it on the edge of the steel and put it in there, and then you fill it up and it just fails. So you have to start a wax and go through the whole thing again. It costs money though. We don't like that.
So you said you heat up the shells to prevent thermal shock. So if you had just had the shell cold before the bronze, it just cracked.
Oh yeah, they're really weak at room temperature, and they get. I've seen them. I've dropped one a foot or so when it's red hot and it didn't break. But if I dropped it at room temperature, it would shatter like. So I don't know what's in there. It's really a pretty interesting material, that ceramic. It's made by a company. They also make a lot of dental supply things and things like that. But casting, they do. Dentists do a lot of centrifugal casting for gold and silver. Maybe not silver, but gold mouth things. Very cool. I've worked at other foundries where we did some centrifugal casting first, but that's more jewelry type thing where you have to force the metal into very small areas. There's also vacuum casting where you apply vacuum and actually suck the metal into the parts that you want. But we don't. This foundry sort of specializes in larger and modern things because we don't really like that jewelry stuff. It's too fussy. Have plants in it all over it, and so it's got irrigation from the plants.
Oh, that's really cool.
So there's probably 8 or 10 doors everywhere, and they're removable, so he can decide where he wants to put plants or not. It's got a. We use it internally. It's got stainless steel, bronze. You can't weld. Well, you can. People do it all the time, but you shouldn't. Steel and bronze together. Galvanic corrosion.
Right.
The stainless works very well with the bronze. They're very compatible. So we transition from this steel right here is stainless, and that's what's welded all inside.
The galvanic corrosion will be really bad on something that's like a water piece, right?
Yes. Yeah. Water and also dirt in it that's gonna hold water. So yeah.
Trying to like get to the door.
I don't know. I lost count.
So is this like the original, or is this?
That's the maquette. Yeah.
So then you blew it up.
We did not actually. Some artists prefer to do it by hand. So he has a big studio with some assistants, and he actually just had this there, and they built this in full size in plaster.
And then you just had to cut it into a bunch of pieces.
Yeah, we molded it. Actually, it's sort of the same piece. We molded this one piece here, and that's all we did. And then we made 2 wax copies, and then we just altered it to bend here. If you look closely, it's actually 2 pieces that are the same. But with a bend on the bottom, it kind of throws you off. One's upside down and one's... But we could have done that. We could have laser scanned this and carved this at whatever scale in styrofoam. We have done that for him. He did this before he knew about that. Artists love it. It saves them months and months and months of time trying to measure and get everything right. Especially with a human figure or something complex, because you get when you get your foam carved out, you just put clay on it, but you don't have to think about any of the anatomy or dimensions. It's all there, so you're just doing the surface. Materials, that was right up against the bronze. Broken off with a hammer, and then we use an air hammer to finish it off. It's wet, just with water.
What's that thing for?
That's a grill I'm building for myself.
It's all balls on the outside now. Started
It's a
off
600-pound
a bunch
grill.
of flakes, and now they're all kind of together.
It's modeled on Sputnik.
And it's right up against the ceramic there, or right up against the metal.
Then we'll take a plasma cutter. Does everybody know what that is?
Yeah.
Man, those are cool. It's like magic. So we cut the artwork off, and then we're going to keep all those gates in that funnel shape. We're going to remelt those and use those again. And then we go to a sandblaster to get the last bit of that ceramic residue off. That's what it is? Yeah. It's made from a slag, but it's really this material is really sharp and abrasive. And then we have in the smaller one we use glass beads for depending on what surface we want. But these are what the castings look like. Just been plasma cut off and haven't been into the blaster yet. So you can see it's got the residue of the ceramics. And then there's all of our gates and bars. Sometimes we use these for using for structural reasons, but most of it gets mixed back in. We try to use 50-50 new and used metal when we go to work. Really getting expensive now per
Do you
pound.
remove the residue before you? Do you remove the residue before you throw it in?
No, it's bronze is so heavy that stuff just floats right to the top and just give it out.
Oh.
I know that some foundries will use a flux or intensively clean that before it went in there, but we found out that we don't have to, so we're lazy, so we don't do it. We try to be as lazy as possible. You kind of notice we just went in we're trying to make everything easy. That's why we don't pour with hoists. We try to eliminate as many problems as possible. So once we have our pieces, they'll just go on a shelf until we need to assemble them. An artist needs them, something like that. So this is what that's a clean casting ready to be assembled. And you can see we put little wax clips on the end. That's again to reinforce the edges. We have the most problems with flat plates casting because of the hydraulic pressure. They always want to split on the edge, so we put these clips on to try to gather more ceramic and make it stronger. And also these little holes are actually formed ceramic pins between each side of the mold. And then behind you we have 4 welding stations. So everybody has a TIG welder, various air tools to be able to put these things together. And we have some of the different guys have different, they do things better than others. So some guys are better at little tiny fussy stuff, so we'll give them those projects. Some guys are better at the bigger stuff, so. We even have special tools made sometimes for the die grinders that mimics. I copy them with calipers and have a machine shop copy the distance. Sculptors use a tool called a rake that makes a. I don't see. Here's some right here. They use a rake, and we'll have a tool made that copies their rake. So when we weld the thing together, we can just and the weld line goes right. That's the skilled part in here, is making all the welds disappear so they're undetectable to most people. First thing we do when anybody works in a foundry goes to a museum is, I see the seam right there. Yeah, that's pretty cool. We do one this tall too.
That was here a year ago, actually.
And you saw one? We've done 4 or 5 of them. This one's interesting because the original of this was actually done with rapid prototyping. So this was printed originally, and then we made a mold of it and then cast it in the middle. Because the sculpture was done in software. I don't know if you guys know what. See, you'll see. I'll leave that for Tony. That's the next section. It's the same software they use for movies and video games. It's virtual sculpting with virtual clay. It's pretty neat.
The link up between this side and that side is mold making. So what happens here is we take whatever we've done over here, or a small piece the artist has brought in, and we have to get a really tight negative image of that for the rest of the process that you guys have seen and that you guys are going to see. So the way that's done is with a rubber sprayed with this. So it's a two-part polyurethane rubber. And once Siobhan, who works here, has put all the seams on a piece, decided where it's going to all divide up, we spray rubber all over it to the thickness that we want, and then we put plaster jacket on top, which is just, it's not really plaster, but it's FGR, fiberglass. It's hard, so it holds the shape. So the rubber captures the print, and this holds the shape. And then when we take all that apart, we take it off the original. The original is pretty much wasted. Everything here is pretty much done for process, so everything is a model for bronze casting. So we don't really care about the original too much, no matter how long the artist has spent on it. Usually it doesn't make it through all the violence that's done to it throughout. So we're just after the negative of whatever came in the front door or whatever we produced here. And once we have that negative print, it goes over to the wax room and we get a positive hollow wax copy out of it. Any questions? Do you have any questions, Jay?
Quick lunch.
All right. This is all like the cold work that's done in the foundry. So this is all enlarging, digital enlarging, point up, sculpting, all of that. So yeah, that's just employees all done really big. So in this room, this part is the part that's not normally in a foundry. It's pretty particular to this place and maybe a couple other foundries in the country. That part is the foundry part. This part is more, it uses a lot of technology in this part, hardware and software. So that starts in this room. Does anybody have any questions about that? So this room, everything's kind of a wreck right now because we're moving everything around, getting more space, putting this room in the front room and whatnot. But this room is where we capture the digital information from a small piece, maquette size, in order to blow it up any size. And that's done using laser scanning, or we directly model something. If we want it large, we just, once it's in software, we scale it to another size, and then it gets tool pathed, gets cut up, tool path for the machinery, and it goes out, and we carve it with the tools out there in foam. Then it gets assembled, coated in a thin coat of clay, and sculpted, and then it goes through the rest of the process that you've seen. It goes over to mold and then through. So it's a way to make a small part a big part, and that's pretty much that's always been done by artisans. The artists don't have enough time to point up pieces. It used to take about probably a crew of artisans, maybe a month, to point a piece up, measure, build, measure, build. Now it's all done within days. At least a lot of the hard work is done, and then it's just fun. It takes all the drudgery out. Basically, it allows me to blow this up to whatever scale she wants, and then we can immediately start sculpting on it with clay to make it look really nice. We also build stuff directly out of software in this room, which means we don't have to have a model in order to make a real item. We just need an idea or a sketch. So, like something like this was made completely in software. So this one didn't exist until I made it from a painting, from an artist's painting. I made it into a piece of sculpture, and then it got output through the machinery to about 4 feet high on this one. And it gets output as a three-dimensional print, and then sent through process small too. So this was, look, just almost just like that, but it's gotten cut up for mold making. And this actually exists in the back as a small piece. And exists in a crate right there as a big piece. Any questions? They're all just controlled, this machine's controlled with a computer that's in the computer room. This is just a 4-axis CNC. It's only using 3 of those axes now. The other one is underneath the table, so it'll spin a block of foam as well and carve it. This is a very small, thin piece for us to do. Normally we carve with a bit like this, like the one you see on the robot, which allows us, it's tapered, because if it wasn't tapered, these spindles spin so fast it'd be like a piece of spaghetti and it would fly off and kill somebody. So they're all tapered. And this constitutes its maximum carve about 1 foot on this machine. That one really has no maximum carve because it's a robot arm. So after normally we're carving something much larger in this machine, and then it gets assembled. In this case, we're carving with a 5/16 bit because we're only carving about 1.5 inches down, because this is part of a giant form liner for I-10. So I-10 Prince Road, we're making, which is right behind you. So that's a negative image of very, like a 15 by 30 foot form liner. So once we have all these carved, we'll dress them up a bit, assemble them so that they all go together on site on a big form. They put that up against their wall, their concrete wall they're going to pour, and then they pour concrete in and fill it up. So along I-10 Prince Road, there's 4 of these images along the roadway. Then they paint them all up and whatnot. So this is a pair of boots from a mariachi. That's just one small part. I think the head, there's 2 of them, their heads are like this. It's really big, but it's very, very low relief. So I had to take the artist's original and massage it in software in order to bump everything a lot more, use the whole 1.5 inches that I had. It's like kind of making a coin and putting it on a big wall. It's hard to see at 80 miles an hour speeding down the highway. So it's all been fooled with in software. Hence why you've got all these planes, because I made it simpler and then I bumped everything, all the maximum depths I could get out of it, in order so that when they poured the concrete in, you'd be able to read it on the wall. Otherwise you wouldn't have been able to. It's very large. This will probably take about a week to process 1 form liner on this, because there's 14 cards. They each take about 6-7 hours. So we usually process 2 a day for about a week.
Does it take a lot to convince the artist to let you do that sort of thing where you can change it up, or do they mostly just trust you?
It depends on the artist. I mean, going in, they sort of knew.
Yeah.
I had them in, and we went through some different software things, and I'm like, well, what do you think of this? And they liked it. It depends. You know, some of the artists give us a lot of power here, and some don't, and that just depends on what they want. I mean, everybody here is a trained sculptor. Most of them are U of A graduates, so we finish work, we finish it mostly, and the artist finishes the last part. We work with the artist. I mean, this is an artisan shop, so it's a collaboration all the way through. This, you can see the process on this. Believe it or not, this is a well-known painter out of Vancouver, and this is pointed off of one of his paintings for some show in Paris. And this is all just foam. This metal part you see here is just holding it up and keeping the weight off the little tiny legs because of the massive head. But this whole thing, if I cut it off, I could throw it across the room. It's just foam. It's got a very small coat of clay on top of it that's been dialed in and sculpted to the surface that he wants. When it's all done, We'll send it over, and a mold will be made, and it'll go through process. Just like it'll just run through the rest of the shop. So everything off of this machinery, everything in there, and off the machinery, it gets all put into a larger item back here and sculpted by the artisans here and the artists in order to come up with a giant piece for public display, usually, the big pieces. That behind you is the robot. So that's brand new technology. It's operational, it works fine, but we're waiting on a 7th axis from Italy, which will go in front of it here, so that when it carves, it'll all move like this while it's carving. Because that thing has 6 axes and it'll carve just like your arm. So you can carve massive blocks of foam with it. I mean, they use them in Italy to carve marble. The only place we can really get proper software and hardware integration is Italy, because they've jumped on the boat in order to do marble reproductions of Italian marbles, and they use robots to carve them. Different top part, but same exact software. For the most part, the same exact hardware. It's just a repurposed automotive robot. And it's quite powerful. But these are the servo drives for the axes on this robot. The servo drives on that machine are those little black hands you see. So there's quite a bit of difference between this and that. This will just rip your head off or do whatever. It doesn't care. It's very, very dangerous. It'll have like a thing around it and a light curtain so that if anybody goes through, it'll shut itself off. But right now we're still waiting to integrate it completely, so we're waiting on the part and the integration to get the 7th axis here, and then we'll have to close it all off, because it's awesome. It's really cool.